Hello everyone. So today's our topic is successive differentiation under the chapter of differential calculus 1. So if you consider what is in the successive differentiation, it is nothing but doing the derivation for again and again for the same function, like do multiple times of doing the derivation for the same function. If you are considering function as y is equal to f of x, and the first derivation for this function can be written as y1 is equal to dy by dx, and also can be written as capital dy. Here capital D is equal to d by dx. Suppose if you are going to do the second term, it can be written as y2 is equal to d square y by dx square. It also can be written as d square y. So here d is equal to d square by dx square. Like this it will go on. By using this similar pattern, we can derive the nth derivative of that particular function as yn is equal to d power n y divided by dx power n. And it also can be written as d power n y. It is the nth derivative of the particular function. I am just taking the simple example. Suppose if you consider some standard functions, because why we are finding the derivation for these standard function, in the future if you have similar example found as like these patterns, we can use that formula so that we can derive the answers easily. Suppose if you consider the first standard function, that is y is equal to e power ax. Suppose if we do the first time derivation for this function, then the y1 can be written as d by dx of e power ax. But we already know that derivation of e power x is equal to e power x itself. But in the place of x we have ax. If we consider this ax as x, then the derivation of this particular function becomes e power ax itself. But the thing is, in the place of x we have ax, so we have to do the differentiation again, that is d by dx of ax. So it becomes e power ax into a, also can be written as a into e power ax. Suppose if we do the differentiation again, then the y2 can be written as d by dx of, double derivative of this derivation function, that what we got, e power ax. So here if you see a is the constant, so constant will comes to the first, then again we have to do the differentiation for this function. We already did the differentiation for this function at this here, so from that equation we can written it as like a into e power ax. So with multiplying this we will get a square into e power ax. Similarly if you do that again for y3, we will get a cube into e power x, like that, so on. So from above patterns, we can find the nth derivative as yn is equal to a power n into e power ax.